Thank you for coming all. My name is Marcelo. I'm a staff engineer at ANZ. And today we're going to be talking about Swift Registry and dependencies outside of GitHub. So we will start this with a bit of a side story / side quest. Does anybody know what Figlets are? There you go. People nodding are giving away their ages, possibly. But Figlet is a pretty old tool from the early eras of the internet, where it is able to generate text out of text. It's like art out of textile. So you can generate fonts like that, like this, or like this, or like this, like this. And the reason I'm talking about it is because I really, really like Figlet. And I also really, really like Swift. So, of course, I will do a Swift Figlet. And you ask me why, and I say because I want to. So let's do a little demo of what I got here. I'm going to be turning my head a lot this way today. So this is Swift Figlet is running in Xcode 26. And if I show you what the code is about, you'll see that's pretty simple. It's just one file, and it's based on argument parser. It receives one argument, and then it finds the directory where the fonts are by doing a Figlet command using the swell command line tool that I go into details later. Then it lists all the fonts that are available by using swell again and doing an ls in that directory, and then it chooses a random font or falls back to standard if none is found, and then it runs Figlet, passing the font through. And if I run it, did I press the right button? Cool. Let me try and expand this. Right, so it's missing the argument, so I'll just pass in some arguments here in my execution. Oops. Just give me 1 second. Edit scheme. I'll add an argument, and I will do, say, hello dev world. Is that right? Yep. So I'll hit an enter. I'll do a close, and I will extend this side of the screen by carefully clicking those buttons, and then I'll click on play again. That's it. It's great. I can keep on running this forever. It's such a unique experience every time you run it. It's great. Anyway, breaking this down, I showed you that we're using a library that's called Swell. And Swell is a library that, as you can see, is in GitHub, right? It's using version 0.03. And Swell is being provided by GitHub, and it's an open source library that's in GitHub, done by this random dude that I found online. And everything is great. You got what I need, you got it running, but there is an issue, because I mentioned I work for ANZ, but I actually work for BOCC, which is called Big Omnibus Close Corp. And BOCC, which, hold on, here's my name tag. BOCC on Swell, because I did it on my work time, and BOCC will not GitHub. So the issue that I have right now is that I cannot run my beloved Swift Figlet tool because BOCC cannot provide it to me. So what can BOCC do to allow me to build my tool and get Swell and get Swift Figlet running? What can it provide me? And that's where Swift Registry comes in. Claps. Thank you. So Swift Registry is a specification of a service that came online for, it was 2022. It was implemented for Swift 5.7, which came with Xcode 14. It came up with the Swift Evolution proposal 292 back in the day, and it's honestly it's not a complicated proposal. All the documentation is online as part of the Swift Package Manager documentation, and it basically specifies, among details around it, 6 endpoints, and is one endpoint for you to be able, for you as a client, to be able to list all possible packages that have been released, listing the versions of them, and then you can specify a package and fetch specific metadata related to it. You can get the manifest, which would be the package.swift for that specific release. You can then download the actual zip containing the source code that you want to use as a dependency. We're going to talk more about this, but this is a way for you to associate an URL with an identifier in the package registry. And then, of course, you have also a means of actually publishing a package release as well through the service. So let's do a little demo of something that BOCC can do to get the packages running. If I come here to my terminal, I have it open here, the source code of Swell. And what I'm going to do is I'm going to do Swift Package Registry publish. I'm going to do a help because I need help. And then I'm going to specify the package ID, which is going to be bocc.swell. I'm going to do a version 100. Is that correct? This is swell 100. I'm going to specify the URL where I'm running my registry, which is in localhost. HTTP localhost 8080. And in my case, as you noticed, I'm using HTTP server, which requires me to specify that I am allowing it to use a non-TLS, non-HTTPS server, which is allow insecure HTTP. And if I do that, it will work. Yes. So my publish, thank you. My package got published to my internal registry. I'll talk more about the registry soon. But if I go back here to my Swift Piglet source code, before I do this, actually, I might want to come and close Xcode before I change things under it. Yeah, stop tasks, please. Here we are. I'm going to do a Swift package. Package registry. I'm going to do a set. I'm going to do a help again because I need help. And I'm going to do a scope. And the scope that I'm specifying, we're going to get more into scope soon, but the scope that I'm looking for is BOCC. And I'm going to specify and allow insecure HTTP, and I'm going to specify the URL, which is HTTP, localhost 8080. Cool. What this did to me is that it configured the Swift Packet Manager to let it know that the BCC packages, the packages belonging to the scope BCC, are actually pointing to this localhost server. And if I can show you what it created, you see that in SwiftPM/configuration, you created a file called registries.json. That's a simple configuration file that SwiftPM uses to identify where the services are. If I open Xcode again here, there it is. And this is where I want to be right now. I have my package URL pointing to GitHub. I'm going to comment this. and I'm going to do a package. Instead of using an URL, I'm going to specify directly the ID, and the ID is going to be bocc.swell, and I'm going to do a from a version 1.0.0. And before I go ahead and save, I'm also going to change the package name here from swell to bocc.swell. Save. Xcode should try and resolve packages. You can see on the left side over there that I'm actually using swell 100 and it was 003. And if the font is big enough, you'll see that we have a different package icon here showing that this is actually a package from a registry and not directly from software code management like GitHub. If I run this, it's going to build with the new dependency in. And voila. Want to see it again? Anyway, cool. Coming back to my presentation. Now you are an experienced developer, and an experienced developer is skeptical by nature. So you look at BCC showing something cool as this, you question, right? Really, like they cannot pull this off possibly. So what is happening behind the curtains? Well, so what's happening? The Swift Birdhouse is an open source implementation of the Swift Package Registry done by this random guy that I found on the internet as well. And it's an open source implementation of the package registry that was built over Hummingbird. So it is open source, 100% built in Swift over Hummingbird 2, which is lightweight and fast. Okay. So what we are going to do now, we're going to see some demo of the logs that came up. If I come here to my Swift Birdhouse that's running, you'll see that since I started running it, I had first a pull request that was done that actually published the swell 1.0 version, and then when I actually went on Xcode and tried to resolve that package from the registry, it checked which versions were available in it. It checked the metadata related to version 1.0, and then it got the package.swift version. You will notice that there's an endpoint missing here, which is an endpoint where we actually retrieve the actual package zip file. And that's missing because Xcode knew that this was the same package that had cached before when I was preparing for the presentation. Coming back to the presentation, we also want to see some demo endpoints. And to that, I'm going to use an endpoint tool called Rapid API that some folk here might be across or might have had just before. I used to be Paul before. The first endpoint I'm going to showcase is the list package releases. I'm going to call my locally running Swift Birdhouse with a scope that is BOCC and a release named swell. And if I run it, you'll see that I get a response listing that I have the specific releases in, which is only one, version 1, and this is the URL that contains it. If I run the second endpoint, I will be fetching extra metadata about that release, which is the same address added to the version. And if I run it, I can see more information about the release, including some URLs where they were stored in previously. I have a checksum that Swift uses to securely know that release that it had absorbed before is the same later, and it avoids middleman attacks. Licenses, inscription, author, etc. If I run the third endpoint here, is the same as the metadata, but added to a /package.swift. You will see that it will return the actual package.swift of swell. And last, in this sequence of demonstrations, I will download the actual source archive, which is the same address but added to a .zip file. And if I run it, I have what would be a binary of the source archive as well. And that's the dance that Xcode or SwiftPM does to actually retrieve the package. I'll go back to my presentation. So we talked about scopes earlier, right? And you might have guessed already, but scopes are namespaces for the packages that are in Swift registries. And one thing that scopes allow us to do is they allow us to have different packages belonging to different scopes, and each scope could be mapped to a different package registry. So in this case here we have BOC swell, I have byte me pixels, nerdvana glitch, and rf slash. And if I see the config file that these files would have, I would have different URLs for each different scope. And adding to it, I also can have a default scope that is a fallback that if I am trying to use a package that's not specific to any other scopes, then it tries to reach the default URL over there. Cool. Now, one question that you might ask is, what happens when there is a clash of dependencies? Meaning, what happens if byte me /pixels in GitHub is the same as byte me.pixels in the Swift registry? And that's a scenario that can happen when we have, say, Swift gremlins that's depending on byte me.pixels in a registry, but then Swift gremlins also depends on nerdvana glitch, which depends on byte me/pixels in GitHub. But before you figure out what happens on a conflict, we have to understand how does it know it's the same package. Okay, and that's where that fifth endpoint comes in. The lookup package identifier is registered for a URL, which maps an URL, in this case would be the GitHub URL of the package. It maps to an identifier that belongs in this namespace inside the Swift registry. So byte me/pixels can be mapped to byte me.pixels. And we can take a look at a demo by coming to our fifth endpoint that we have here in Rapid API. If I run it passing as a URL parameter, oops, thank you. If I run it passing as URL parameter, the GitHub address of Marcelo-es/swell, you see that it will return boc.swell, which tells SwiftPM that they are the same package. But how can the client fix the resolution? Well, there are three options that the client can go through to choose which package to choose. First of them is the full one, which is disable SCM to registry transformation, and that option simply does not use the endpoint that I just specified. It just lets it clash, and there you're going to have a linker conflict. The second option that you can pass in is use registry identifier for SCM, which means that it's going to go through the Swift registry, it's going to identify that both packages are the same, and it's going to pick up the one from SCM, which in this case is GitHub. And the third option is replace SCM with registry, which means that it's going to go through the same endpoint, it's going to identify that both packages are the same, and then it's going to choose the Swift registry version of the packages. Cool. But sometimes it can happen that not all of us have the luck to be using SwiftPM for package management. Some of us are stuck with Xcode, and I'm sorry. You have to deal with it, but don't worry too much because it can happen. We can make it happen. You can use Xcode for Swift registry package management, but it's a bit of a rocky relationship. So bear with me. We're going to do a little bit of a demo on how Xcode can do it. So, just a second. If I come here, I have this other project running through, which is an actual Swift project. It's not a SwiftPM project, it's an Xcode project that is actually a Mac app called Mac Figlet, and it does pretty much the same thing, but in a Swift UI manner, in that it lists fonts, it finds a random font, etc., and then it prints on the screen. And we got the app here. And what I'm going to do here, you will see that Macfiglet is using the GitHub dependency as a dependency. And for me to be able to use it with the registry, I will start by closing GitHub. Then I will come in the terminal, and unfortunately that command that we did just earlier for setting configuration for a specific SwiftPM project is not available on Xcode. So what I have to do is I have to manually copy the configuration into a folder where Xcode can find the registry. And to do that, I will copy the previous file that we have generated for configuration, which was swiftpiglet .swiftpm .configuration .registries, and I'm going to copy into macfiglet.xcode project. Inside Xcode project, it creates a workspace which is called project.xc workspace. I told you it's rocky relationship. Inside of it, there's going to be a Swift. There's going to be a XC share data, and there's going to be a SwiftPM project, and there's going to be a configuration inside of here, and I have to copy the configuration here and reopen Xcode. Easy. All things considered easy. You chose to be with Xcode, so you would know what you were signing up for. From here on, I can remove this dependency, and I can come back here, and you might have used this field before to search for GitHub dependencies, and in this case here I can just do bocc.swell, enter. Oops, thank you, Bok. There you go. It went into my registry. It found, because we have an association between BOCC and URL, it found the swell inside. It went through the dance of looking for all possible releases of swell. I can add a package. I can just add the package as a dependency, and I will run my little Macfiglet app. And it's going to run on the wrong screen, and I will drag the right screen through. I think I have to. There it is. There you go. Thank you. If I click here, I can see different fonts print on my screen, and I even added this shuffle feature here that every 2 seconds gives me a different font. And there you have it. It's working. Any questions?